In this video, we're going to take a look at Newton's third law of motion. And what Newton's third law of motion states is that for every force that acts on an object, there is a reaction that is equal in magnitude and in opposite direction. You might have heard the phrase before, for every action there's an equal and opposite reaction, or for every action there's an opposite reaction. This is quoting Newton's third law of motion. When we take a look at Newton's third law of motion, what it really tells us is that whenever a force acts on something, forces always come in pairs. So if you were to hit something, or maybe you got frustrated and kicked a wall, not only would you possibly do damage to the wall and the wall would feel the force of your kick, but also your foot would feel the force of the kick from the wall. Anytime that you push on something, you always feel the pressure and the force from your push. So whenever a force is put onto an object, that object puts a force back on the object that's applying the original force to it. The directions are opposite. Forces are vectors, so they do have direction. So if you push on something in one direction, it pushes on you in the opposite direction. Let's take a look at this as an example. In this example, we have a student that pulls a 10-kilogram cart, causing it to accelerate at 2 meters per second squared. So now let's find how much force the student actually places on the wagon. We're going to use force equals mass times acceleration, and we're going to plug in here our mass of 10 kilograms and our acceleration of 2 meters per second squared. If we're accelerating a 10-kilogram cart at 2 meters per second squared, the total force that must be placed on it would be 20 newtons. F equals ma. 10 times 2 is 20 newtons. So if a student places 20 newtons on the cart to get it to move, we want to know how much force the cart is going to put on the student. Well, according to Newton's third law, it's the same exact force, just with an opposite direction. If the student puts 20 newtons on the wagon must put 20 newtons on the student. There's one more example. After that, I suggest that you try the CAS Learning that we've linked to the Nearpod, and then go ahead and answer the form questions.